Alright, let me show you how you can recreate this very cool chart from the Pew Research Center using ggplot. This chart shows you the distribution of different school start dates in different divisions of the US. And it is actually a bit tricky to create because it is a combination of two chart types. First the map charts and then the bar charts, and then you have to figure out how to combine these charts nicely. But let's figure this out when we get there. For now, let's start with the maps. The first thing we want to do is to load the tidyverse, and then to create the maps, we are going to let the US map package do most of the heavy lifting. With that package, it is actually pretty easy to plot a map of the US using the function plot US map, where we want to specify that we want to plot separate states. And then you already get a nice map output. So we are pretty much done here. Anyone else feeling on how to draw an owl vibes yet? In any case, things do get a little bit more complicated when we want to add color highlights to specific divisions of the United States. You see, in the original chart there are always divisions of the US that are highlighted. So we need to figure out how to make this happen with the plot US map function. Therefore, let us open up a new code chunk for this. And the good thing is that the US map package also has a function that can extract the data for the map. And you can see here that this is not very nicely formatted, so let's make this into a table to have a nicer output. Now we can use this to find the data for our division that we want to highlight. Right now, this dataset gives us the map data for all of the states. The good thing is that R has some built-in vectors like this state ABB vector that allows us to get access to all of the state abbreviations. Therefore, we just have to figure out which correspond to a given division. Luckily, we can use another one of R's built-in vectors to filter for a specific division, say Pacific. And this way we get all the state abbreviations that correspond to the division Pacific. So for a given division like Pacific here, we can save all of this into a new vector. And then we can extract the map data for only those states using the include argument from the US map function. This will give us the correct data for only these states, and we should save this into a new variable so that we can reuse that. Now, if you look at the data, you will actually realize that we don't need all of those columns. In our case, we are going to need the X and Y coordinates for the outlines of the state. And we're also going to need the abbreviation of the state, but there's one more thing that we will need, and this is the thing where you can mess up if you don't include it. By which I mean, this is something I badly messed up when I created this video. In any case, what I mean is the group column. That's because the map data of every state isn't just one group, but possibly multiple ones. For example, the state of Hawaii consists out of multiple islands, and each island needs to be drawn separately. So therefore, for each of those islands there is an additional group. And that is why we need to extract the group column as well, so that we can work with the map data. And once we have all the data, we can actually reformat it to nest the data by state and group. Here again, you can see that one state doesn't necessarily consist out of a single group, but can have multiples. Okay, now if we want to highlight a specific region on our map, we need to combine all of these regions into one element so that we can plot this one element on top of our map that we already have. This means that we need to do some spatial calculations, which means that we need to get the data from the tibble into a so-called SF format. Here, SF is the package that does mostly all of the spatial calculations in R. So we're going to reformat the current data column, and for each entry in that column, we're going to take the current entry and we're going to transform the data that we have into an SF object where we specify that the map coordinates come from the X and Y column of the current dataset. And once you execute this, you will see that this data column now contains SF objects, which are the ones we need to do spatial calculations. So let us pull these objects from there, and in the output you can see that you have a bunch of simple feature collections, which I guess is what SF stands for. There's really nothing so simple about these kind of calculations, but that's the name apparently, so let's just roll with it. In any case, you can see here that now you get a lot of simple features that are always of geometry type point. And in the geometry, you can see that these are a bunch of points that are on the outline of the shape that we want to plot. So let's save all of this into a new variable so that we can work with this next. Now what we need to do is to do spatial calculations to get this from point geometry to polygon geometry so that we can later on combine these polygons, and we also want to plot polygons for the states. So this is why we're going to iterate over our list that we've just created, and specifically for each entry of that list, we are going to apply the stCombine function. And you can see that this step has transformed our previous output to geometry sets that use the so-called multi-point geometry. And from there, we can actually cast this to a polygon. You can see that by the fact that the output now mentions polygon geometry. So that's pretty cool. Let's save this into a new list, and then we can start to redraw our map with these polygons. To do so, let us create a new code chunk where we specify a fill color for each state. And then we're going to use the plot_us map function to plot the states, where we are also going to use our new fill color. So this gives us this map here. And since we don't want to have the state outline for each state, but only those that are in the division that we're currently looking at, we are going to use the same color for the outline as well. But for the states in the division that we want to look, we do want to see the outlines, so that is why for now we're going to exclude the states from the current division from the plot. Bam, they're gone now, but don't be afraid, we're going to get them back. We have our list of polygons, remember? That's the data for the missing states. We get that data into the plot by adding a list of GMs on top of our current ggplot. This means we're iterating over a list of polygons, and with each polygon we are going to compute a GMSF layer. So at the end of the day, we are adding a list of ggplot layers to the plot. To do that, we specify that the data for each layer will always come from the current polygon, and the fill color will be the same as before. But the color for the outline will be white and the line width will be 1. And with that, yeah, we have the specific states back. They are in our map again. Now what we want to do is to add a yellow overlay on top of these specific states. Here we cannot simply replace the fill color to yellow, because this would draw the border for each of those states, and we want to have one overlay that draws the border around the union of these states. So we will have to combine these specific states from the list of polygons into one object, and then we add this on top of our current plot. And the way to combine this polygon is to use the reduce function, which takes the list of polygons that we have and basically goes through them one by one and applies the same function at every step of the way. This is a little bit different than the map function, because reduce will actually reuse the result from the previous calculation and stick that into your calculation as well. So you're going to kind of add up all of the results together, hence the name reduce. Here we are going to use the stunion function from the SF package, which will combine two simple features into one. So at the end of this, we will have a multi-polygon which we can save into a new variable. And this is the data that we need to finalize our highlight of the Pacific region. Thus, we add another GMSF layer where we use this combined polygon data and specify the filling color, the alpha transparency, and the line width. And then we get a plot like this. Alternatively, to make the borders between states come out more, we can actually set the fill to NA and remove the transparency since we don't need that anymore, and then we can colorize the states in the previous layer instead. But yeah, we should probably use a nicer color, and we can use a nicer line width as well. But after these changes, that looks pretty cool. So for the maps, we have mostly all of the hard work done. What we can actually do now is to repeat the same steps for any division that we want to highlight. We can do this by simply replacing the word Pacific to say mountain and rerun our code, and it just works. And since we need to create one map for each of those divisions anyway, let us just wrap this logic into a function that takes a division that you want to highlight as an argument. So let's make this into a new code chunk, take all of this code and create a function. Let's call this plot division map and then make this dependent on a selected division. Then we can throw in the code and align it a bit nicer. And finally, we have to replace the state division that we hard-coded in there to the selected division argument. Also, we can make any last-minute changes to our function, like maybe making the fill color a bit lighter. And then let us take our function and check if it works the way we intended to. So let's put mountain here again and rerun this, and whoa! This works nicely and the filled color of the remaining states look a little bit nicer. Now, we could just use the map function again to iterate over all state division names and create a map for each one of those. This would give us a list of division maps, but here it shows us only the last rendered division. But for now, we don't want to do that because we want to make sure that our list of maps is in the correct order later on, so let's save this step for later. But before we move on to bar plots, let me drop in real quick to remind you to hit that like button. This video is actually quite long and quite complex, so it was a ton of work. That's why I would really appreciate it if you hit that like button. Thank you for that. Now let's get back to the bar charts. In the next step, we want to work on the bar plots. Here you can see that it's basically a labeled bar plot showing on the x-axis different date ranges, and on the y-axis we have the share of public schools. We have to watch out here a little bit because there's a difference between zeros and stars in the chart. And if you scroll down, you will see that actually stars mean that no sample districts in the region resumed class in that week, which is different than the computed 0. Now, to get this data into R, I did a pro thing and typed it all out into a CSV file that we can just import. To do that, we just create a new code chunk and call read CSV, where we, well, read in the CSV file. And for some reasons, some of these columns are interpreted as numbers, some of them not, so this is why I enforce that everything is interpreted as a character. And also notice that in the column names, I have already put in the break line characters to create the line breaks that you have seen in the final chart. Next, to get this into a good data format for ggplot, let's call pivot longer, where we rearrange everything but the first column and we map the names to new date column and the values to the school columns. Now we have to do a little bit of formatting here because you can see in the date column there is a double \n and we need a regular \n for line breaks. Therefore, the first step is to string replace in the date column the fixed term \n with only \n. Nice, with that we actually have line breaks in this date column now. And then we're going to transform this column into a factor variable where we use the order the dates are currently in as the levels for that factor. This way we can always be sure that in our plot later on, everything is sorted in the correct order. And the same thing should be done for the division. Next, we have to convert the school numbers to actual numeric numbers for the bar charts. But we also have to preserve the stars in that column. So that is why we do not convert this column, but create a new column which we call schools numeric. And there we transform the text to numbers by the parseNumber function, but first we have to transform the stars to zeros in order to avoid errors. This gives us a new numeric column that can be used to create the height of the bar columns in our bar chart. And the regular schools column can still be used to create the text labels for all of those columns. Therefore, let's save all of this into a new variable. Next, we should work on the bar charts themselves. Since we have to do this for each division, let us filter our division for a selected division first. This gives us the data for one division that we also save into a new variable. And now, to create the bar charts, the code is pretty straightforward if you have worked with ggplot before. You take your data set, pass it to ggplot and specify that on the x-axis you want to have the dates, on the y-axis you want to have the numeric data, and then you simply add a gmcall to this where you specify the fill aesthetic. Now again, this is in the correct order on the x-axis because we have formatted the date column to a factor variable. Otherwise, ggplot might have sorted this alphabetically, which is not something we want to do here. It just doesn't make any sense for this time data. Now let's add the actual text columns to our bar charts via gmtext. All we have to do here is to specify our labels, and here we can use our labels column for this. This way we also include the stars labels when we have one, which we don't have in this division. So let's maybe just change this into Pacific. Also no, maybe East, South, Central. Oh yeah, here's one. So let's go with this division. Now we can format the labels a little bit by changing the vertical justification, making the font to Source Sans Pro, changing the color and setting a new size. Notice that I have set two separate sizes for the star and the regular numbers here. That's just because if we had the star at the same size, the stars would look a little bit weird. So if we put 4.5 here, the stars would be smaller. So this is why I decided to make the sizes different to make it look nicer. Honestly, all of the numbers we put into this for size and position do not matter at all in the view we currently have. Once you put everything together with the map charts, things will look differently anyway because font sizes are given in absolute terms rather than relative terms. So that is why the output here may feel weird to you. If you're rebuilding this, don't try to fix this at this stage. I promise you, in the end, these numbers will look good. And finally, let us add a little bit of nudging to the y-axis to move the labels a little bit. Here again, I have used different nudge amounts for the star compared to the numbers. And again, these are the final numbers that I have used in our code so that the final plot looks good later on. Right now, the plot output looks terrible, but it will look good later on. Now, to round everything off, let us add a horizontal line as the baseline for the bars, set the y limits for this chord Cartesian system from 0 to 100, make sure that we can write outside of the plot panel, which will be important later on, and turn off the expansion so that the bar labels are close to the actual bars. And finally, since our final bar chart won't have any theming, let's add a theme void here. Admittedly, this looks terrible right now. I promise you, once we assemble everything, this will look good. So cool, now we are able to create a bar chart for one specific division. Let's take all of this code and wrap this into a new function that we call plot bars division, where again we use the selected division as a variable. And then we throw in our code from before, we align everything so that it looks good, and then we simply replace the division that we hard-coded with the one that the function should use. Since we have this function now, we can create bar charts for every division by iterating over all the levels from our division column in our dataset and applying those levels in the plot bars division function. And if you execute this will generate all of the bar charts that we can save into new list. And we do the exact same thing for the maps now, where we use map to iterate over the same thing, but we use the plot division map function instead. Therefore, once we execute this, we get all the bars and all the maps in the list. Alright, now comes the fun part, or the hard part, depending on how you want to think about this. What we need to do next is assembling the parts into one final image. This means that we have to think about the size of our image, and one step we need for that is to set our image size to its final size. And to do that, we are going to define the ratio of height to width. These are the things I've just measured out from the original image. It was approximately 1200 by 500 pixels. And then we're going to specify the width of our image too. In this case, I want to have an image that will have 12 centimeters in width. And for all of this to actually have an effect, I'm going to start my camcorder by calling ggrecord from the camcorder package, where I specify that all plots will immediately be rendered to images and exported into a new directory with the image using a width of 12, a height that corresponds to the width times the ratio, and all of this is in centimeters. We are also going to use a resolution of 300 dpi, which is perfect for this kind of setting, and we always want to get images that have a white background. And once I run this, all of my plots that I create will now be displayed in the viewer window and not in the plot window. I can demonstrate this by taking our list of bar plots and then accessing, say, the first element. And you can see now that this is displayed in the viewer window and the bars look different. The bars still look terrible, but differently terrible. Again, this will change as soon as we assemble everything, and this is what we're going to do next. For this, we are going to add a new code chunk and we're going to call the patchwork package. This is the premier package that allows us to assemble plots very easily, like setting them side by side with one line of code. Here, what we need to do is to iterate over both our list of bar plots and our list of maps, where we always take one of each and put them side by side. And then we're going to add a plot layout function on top of this to indicate that the widths of the plots are not supposed to be equal, but the left chart is supposed to be smaller than the right chart. In this case, this means that the map is smaller than the bars. And if you execute this, you will get a list of combined plots. Here you can see the result for the last entry of the list of combined plots. But this is not the final image that we want. We now want to put all of the results that we have inside of here to be stacked on top of each other. So we're going to pass the result that we got to the reduce function again. And in this case, the function that you want to apply is the operator from patchwork that puts plots not next to each other but below each other. And this is just as easy as before, it is just this divide operator. And now if you execute this, you will get a chart that looks like this. Notice that this is in the plots window again because patchwork has a kind of weird habit of deactivating the camcorder once you call the package. So we have to re-execute this part again. And then look, it comes up in the viewers window and it is in the format that we want. Notice that the text labels on the bar charts already look better. This is what I've been saying the whole time. Alright, we're getting closer to the final image. We have all the chart elements in there. Now it's time to add some labels that the original chart has, like the title, subtitle and caption. Therefore, we should add all of that as well by creating variables that have all of that text stuffed inside of them. And now that we have these variables, we can simply add the labels to our patchwork by adding the plot annotation function, which can, just like the labs function, set stuff like title, subtitle and caption. Now these labels don't look that great, so let's change the theme of just the annotations using the theme argument, in which we call the theme function that you know from ggplot. A special case of the plot annotation function here is that inside of this theme argument, only the theme argument that relate to the captions, title and subtitle actually work. Here we are going to format the plot title by making it bold, setting the color, changing the font family and the size, and we're going to add a little bit of margins on top. The last step is important because we need some space to draw a line there because the original image has a line there too. And then we're going to do a very similar thing for the subtitle, that is, we make it italic, a little bit gray, and we add some margin below the subtitle because we need room for the bar chart labels. And finally, we are going to do the same thing for the plot captions. Here, the most important part is left aligning everything and adding some room below the caption. All in all, I'd say that this is a pretty good intermediate data viz, so let's save this into a new variable. This new variable is helpful because it can be used to get access to each subplot in our patchwork. For example, we could still access the first row of our patchwork by calling plt and then its first element. Similarly, if we want to drill down even further, we can access our bar chart using the second element from that first row. All of that is important because on our final chart, we want to modify the bar chart that is at the top to add annotations to include the axis labels. After all, that is why we have left some room there. So let's add the labels by accessing that bar chart and overwriting it in place, which means that we just take it and we add an annotate layer to this. And inside of this annotate layer, you just work like you normally would. That is, you specify that you want to have a text annotation, you set the x coordinate of the labels, and you set the y coordinate to 120. Remember that our coord Cartesian call for the bar charts limited the y-axis to 100. So this is why we enable that we can draw outside of the plotting area, otherwise our text labels at y equal to 120 would not be visible. Finally, we specify the labels and we throw some formatting in there. And now calling the plt variable again after overwriting the first bar chart, you see that your labels are right where they are supposed to be. Now what's still missing are the text labels for the divisions on the maps and the horizontal lines at the top and bottom of the chart, as well as the Pew Research Center branding at the bottom of the chart. Unfortunately, we cannot use the same annotate trick for all of these things, because this annotate trick has its limit. Using annotate allows us to draw outside the plot grid panel, but not outside the whole plot. Instead, what we need to do here is to go a little bit more advanced and use annotation custom. This one can go beyond the whole plot, but it requires that we do not use the GMs from ggplot that we typically use. Instead, we use graphical objects, so-called grobs. These are the things that ggplot uses behind the scenes. For example, to draw a line, we need to use the lines grob and specify the x and y coordinates of the line that is supposed to be drawn in a specific unit. In this case, we are going to add coordinates in the unit of NPC, where the whole plotting area goes from 0 to 1 NPC on the x-axis and the same thing for the y-axis. Thus, if we go higher than 1 or lower than 0, we can actually draw outside of the whole plotting area, which is what we need. And doing the same thing for the y-axis, we can execute this code, but only if we add the library grid to the packages that we load. Now, if we do that, you can see that we have added the line at the top. Once again, finding out these coordinates here is just a matter of playing around with the coordinates until the line is where it's supposed to be. Now, with the same logic, we could just copy and paste this part and throw in more lines and also the text labels. But that is a bit tedious. So instead, what we're going to do is we're going to take that part and throw everything into a grob tree, which is just a collection of graphical objects. The code still works the same, but now we can add more graphical objects into this grob tree, like for example adding another line at the bottom of the chart. And similarly, we can add a text grob where we plot the text Pew Research Center at a specific coordinate. And if we execute this, we have the text there, but we should probably left align the text, and so we set hjust in there. But it still doesn't look too good, so we should also change the look a bit. This requires changing the graphical parameters in the gp arguments using the gpar function. And then we set stuff like the color, the font family, and the font size. And with the same logic, I can add a small text as a disclaimer that this is a ggplot remake by me and not the actual original. Very nice, we have added in almost all of the stuff that we need. The one thing that is missing are the division labels on the maps, but we can throw that in using text grubs as well. The one thing we have to watch out for is that we cannot add the text grubs to this specific part of our patchwork, but we need to add the text labels to the chart that was added to the patchwork last. This avoids overplotting our text labels. We didn't have that problem before because we always added stuff outside of the plotting area anyway, so nothing could be overplotted. So this is why we have to access the last row now. And from there we can add another annotation custom where we throw in a text grob in which we have all the division labels. And then for each of those labels, we really have to figure out good values for the coordinates. It's not a fun thing to do, but that's just what it is. Finally, we also set the graphical parameters for these labels, and then at last, drum roll please, if we execute all of this, bam, we have finished our plot. And it looks very nice. Good job everyone. Now you're probably itching to see more complex ggplot stuff, so check out another chart I created from the Pew Research Center. It is actually a bit easier than this one here. You can think of that video as a cool down workout compared to this video here. Finally, don't forget to hit that like button. This video was a ton of work. Thanks for watching and I will see you in the next video.